Hello everyone, myself Shivansh, first year student of BSc Honours Electronics at Acharya Narendra College, University of Delhi. And in this video, I will be explaining an experiment to determine value of Planck's constant by using LEDs of different wavelengths. So, first of all, I will be explaining some theoretical part of the experiment. Then after, I will be shifting to the virtual lab for further procedure and simulation. So, in simple terms, Planck's constant symbolized as h relates the energy in one quantum photon of electromagnetic radiation to the frequency of that radiation. So as you all can see here, there is an aim to determine the value of Planck's constant by using LEDs of different wavelengths. We will be using two types of software, Multisim and Virtual Lab. But in this video, I will be simulating on Virtual Lab. So a brief theory part, you can see that this is a famous equation. Quanta of energy E relates with frequency of light as E is equals to h nu, where h is the Planck's constant. And in this experiment, we will be defining the value of Planck's constant using some sorts of LEDs. So there is a simple theory part. The hole lie in the valence band while the free electrons are in the conduction band. When there is a forward bias in the PN junction, that is when the positive terminal of the LED is connected to the positive terminal of battery and the negative one is connected to the negative terminal of the battery, then the electron, which is a part of the n-type semiconductor material, would overrun the PN junction and join with the holes in the p-type semiconductor material. So as you all can see here, a simple diagram of LED where you can see that there is a p-type of material which is combined with the n-type of material, and when we apply a forward biasing in it, the visible range of frequency is emitted so that we can see that the LED is glowing. So now let us consider that for an LED, some sort of wavelength lambda is emitted by the LED. So we all know that each quanta of energy is related with E is equals to hc by lambda. And also we know that equivalent electrical energy that must be turned on the LED is evaluated as E is equals to EV naught, where V naught is nothing but the turn on voltage of the LED. So both the energy can be compared to each other, and from this we can get a formula where we are relating V naught, that is the turn on voltage of an LED, with the value of wavelength and the charge of electron, speed of light, and the universal Planck's constant. So in this experiment, what we will be doing is we will be evaluating V naught for different colors of LEDs. As we all know that lambda is different for different colors, that you can see here, that red color has a wavelength of 695 nanometer. So this is a theoretical value of V naught. We can see that for red it is 1.7895 volts. So when we will be applying 1.7895 volt here and applying the volt value of wavelength here, then we can find the value of h, which is our aim to find. Now in this experiment we will be further plotting a graph where we will be plotting on y-axis the current, and on x-axis we will be plotting voltage, and we will be getting some kind of graph which is shown here. And this is other kind of simulation course on the software called Multisim. In this also we have done the same procedure, but it is a little clished process, so I will be explaining all these things on the virtual lab platform. So let us shift to the very famous VLab platform. So now we are shifted in this platform called VLab, and in this experiment these are the apparatus. Here it is a battery, a switch, a rheostat, a resistor, an emitter, a voltmeter, and an LED. So first of all, we will be making connections by seeing this circuit diagram which is provided by the lab itself, and making the all the connections correctly. So let me make the connection first, then I will be explaining. So now I think the connections are made according to the circuit which is shown here, and it is nothing but we are applying a different type of voltage, or you can say different values of voltage on LED, and we will be noting it down that on what voltage we will be getting the LED to glow. So first of all, we will be inserting the key, that is we will be starting our circuit. So now we all can see that our circuit is connected properly, that we are getting the readings on voltmeter and ammeter. And we have five kinds of LEDs here, which we can vary and find the value of turn on voltage, or the minimum voltage after which the LED start glowing. So there is a knob called rheostat value, that is the knob which will be shifting from here to here, and the release of voltage will be occurring on the LED. So let us move the knob and see when our LED start glowing. As you can see, I am increasing the knob, and the value of voltmeter is also increasing, that this amount of voltage is applied across the LED, but we can't see that LED is glowing. So we will keep on increasing the value and will reach to that value, after which the LED start glowing. So let us wait and see when the LED start glowing. So we will keep on increasing the voltage. As you all can see that we have applied 1.8 volts to the LED. Now you can see that at voltage 1.908 volt, our LED started glowing, and we got the value of current on ammeter also. That is, we can say that we have got the value of V naught, that is 1.908, and we also know the red LED's wavelength is 650 nanometer. So we will be applying the formula on our equation, and we will see that what is the value of Planck's constant we are getting for red LED. Then similarly we will change the LED and again change the value of rheostat and note down the minimum value of voltage above which the LED start glowing. As you all can see that for red it is 1.908 volt, and the frequency of red light is 650 nanometers. So let us perform a simple calculation and check what is the value of Planck's constant coming by this experiment. So after performing experiment for all the colors of LEDs, we have got this type of observation table, where we have got the value of V naught from the experiment, and wavelength lambda, that is given in our simulation software itself. So these are the values which we are getting in experimental setup. And then after, we have plotted the IV graph for the same, and we can come to the conclusion that the value of Planck's constant H has been determined accurately by measuring turn on voltage of LEDs of different wavelengths. As you all can see that we are getting an accurate value of 1 decimal point, and the power of 10 power minus 34 is constant all in all the colors. So we can predict that our experiment is successful. Thank you.